Okay, everyone, let's get started.
Exists. Anyway, thank you.
So, today I'll probably be done early, probably about an hour left over at the end. So I'll use that time to go over SPSS again, try to kind of walk you guys through that. Assuming there's no event after the class, which there usually isn't. Last week we got unlucky. I'm also able to stay late if you want help with doing that. Because as I will remind you at the end of class, next week is test 2. The week after that, your paper draft is due. So that's 5%. So you have to send that, well, you have to upload it to me via Blackboard and email it to your partner. And reminder, if you're watching this at home, you need a partner for that time. You're going to exchange papers and then do peer review. Some questions I got before class that I'll just answer for everybody. If anyone left certain questions blank, just leave that would be my recommendation. There are choices you have. I mean, you can just choose to exclude anyone who didn't finish all the questions. That's allowed. One thing that some people do is what's called mean value imputation, where anyone who left something blank, you just add the average score for that variable so it doesn't affect things. I don't personally recommend that, but that is available to you. Some people do that. And someone came up to me and they were worried that they had big p-values. I just want to say, I fully expect that most of you will have non-significant results. That's totally fine. Like, I'm not going to take away marks if it's not significant. That would be very strange. Yep.
So how do we, so we literally will probably just be writing in our paper instead.
Yes.
So there's like, how do we really add more to the paper? Like, well, none of this.
And, just like, there's different ways of waxing poetic. I mean, if you wanted to, this would be going stronger than you should. You could treat it as a disconfirmation of your hypothesis. Like, we predicted this, turns out that might not be true. That's probably putting more value in a null result than you should, especially because it's a small sample size. Here's what I'll say. I'm not going to be, well, depending on how much you wax, but I'm not going to be so harsh with that. I understand you kind of have to build something out of nothing with the results that you have, so I'm going to be somewhat forgiving with that. Any other general questions about the paper? I mean, I'll say a bit more at the end when we go through SPSS, but... Okay, so today we have 2 chapters to cover, which are the last 2 before test 2. So test 2 is, as always, on 4 chapters. So this time it's Appendix B, and then chapters 5 through 7. So chapter 6 is on measurement. So a reminder of something we've already talked about. So there's the variable that you're interested in, or a related phrase that's important in psychology is the theoretical construct. So this could be, intelligence, anxiety, or what have you. And at least in terms of how psychology is done today, this will often be defined in terms of a theory. But we want to nail ourselves down to something that's more precise and well-defined, so we give an operational definition. Right? Some kind of precise, measurable definition of the variable in question. So if the variable or construct is anxiety, you might give the operational definition of galvanic skin response. Or your operational definition might be an anxiety scale, like an anxiety questionnaire. The most famous example in psychology, of course, is intelligence, right? If the variable in question is intelligence, the operational definition is typically some kind of IQ test. a large chunk of this chapter is devoted to evaluating how good the operational definitions are. Right? Basically, are these any good? Not all operational definitions are created equal. So, the score that someone gets on a particular test is thought to result from two different things. This is one of those cases where the definitions here are a bit more theoretical, so sort of keep them at the back of your head. So there's the actual score someone gets, let's say on an IQ test. The two contributions to that, the book uses the phrases the true score. I'm not sure I love that way of putting it, but that's the term the book uses. The true score and measurement error. So sort of two arrows, two things that give you this. So in the case of an IQ test, the true score would be sort of how smart you really are. Or if you don't like that way of putting it, the score someone would get under ideal conditions. Measurement error is all the other variables that contribute to someone getting the score they get on the test. Yeah, so all the other variables, the variables other than intelligence that contribute to someone getting this, a particular score on an IQ test. So, you know, you can think of things like you didn't eat well that day, you sneezed during the test. You don't feel, did you actually just sneeze?
Yeah.
Oh, there you go.
I actually did. When you said that, I was like,
There you go.
I'm about to sneeze.
Ben is right. ESP is real after all. You know, things like motivation. How motivated are you on that day to do well on that test? Things that you wouldn't think of as intelligence, but they still contribute to how well someone does on the test. So as I say, not all operational definitions are created equal. Some are better than others. And there are two main good-making properties that tests can have. You probably would have been exposed to this in intro, at least to some degree. And those are reliability and validity. My classes mix together in my mind. Have we talked about these yet?
Validity is that.
Validity we have, reliability no?
Not really.
Okay, so I'll do reliability first. So reliability is about how consistent a test is. Or you could say, how consistent are the results it gives you? So it's about consistency. The first kind of reliability, which is usually the example that people will give in intro psych, is test, retest reliability. So I'll stick with IQ. It's an easy example to use. So I give Bob an IQ test. It's my new IQ test that I made. And I give it to him on Monday, and he gets 138. I give it to him on Saturday, he gets 73. That's not good. That would be low test-retest reliability. If he gets 138 one day and 136 another day, okay, that's pretty good. By the standards of psychology, we would be pretty impressed with that. Now, that's just using one person as an example, but obviously we want to do this with a big sample. So what you would actually do is give a sample of people an IQ test twice. You measure their score at time 1 and their score at time 2, and then you just do a standard Pearson correlation coefficient, right? The higher the correlation between people's scores at time 1 and time 2, the higher the test-retest reliability is. So if it looks something like this, you're happy, right? That's an indication of high reliability. Does the first kind make sense? Okay, the second one, which in my experience is the most commonly used, is internal reliability. Also called in the book internal consistency. So suppose you're lazy and you don't want to give people IQ tests more than once. You just give it to them once and then look at how much the items within the scale correlate with each other. The more the items within the test correlate with each other, the higher the internal consistency. Yep, so if you want the short definition, internal reliability is the extent to which items within the test correlate with each other. On this front, IQ tests do quite well. This is why we are able to extract the G factor. If you remember from intro, the G factor captures the extent to which items in IQ tests positively correlate with each other. And they do reasonably highly, which means they have high internal reliability. Yep.
When you say items, do you mean like chunks, like chapters in the test, or like groups?
There's different ways of doing it. You can do it literally with individual items. And so what I'm building up to is the term Cronbach's alpha, which basically is a measure of how much the items correlate with each other on average. At least that's good enough for this level. Yeah.
I think the book says it a little differently for internal reliability. It says that it's the degree to which the items are consistent in measuring the same variable, but you said...
Yeah, that's building, I think, too much into it. The actual measures of internal reliability are just measures of how much the items positively correlate with each other. Like, so Cronbach's alpha is one measure of internal reliability. Yeah, so I wouldn't say it that way. So what is true, maybe what the book is getting at, is reliability is generally thought to be a precursor or a necessary condition for validity, which is more what that definition is getting at. Textbooks are not written by God. But where was I going with this? So building off of this, one of the main and probably the most popular measure of internal reliability is Cronbach's alpha, which is a measure of how much the items within, measure how much the items within the test positively correlate with each other. So for both of these two, around 0.7 to 0.8 is often used as a kind of minimum amount. If you want to argue that the test is reliable, you want at least that much. If it's lower than that, a few things could be going on. It could be that it's measuring more than one thing. It's not really just one construct. Or, in my case, in some of my studies, there's too few items. If your scale has fewer items, this tends to be lower. So I used in my experiments in my dissertation something called the cognitive reflection test, and don't worry too much about this logic, but it only had 3 items, and the Cronbach's alpha was around 0.5 in most of my studies. The way one of my someone on my committee put this to me is, imagine you're a good student, and you have to choose between a 50-item test and a 3-item test. If you're a good student, you want the 50-item test, because if it's 3, let's say there's just one term, let's say it's like my class, there's one term you don't know, like of all the terms. If it's 3 items, you're screwed, right? Because now you get 66%. So basically, if you have fewer items, measurement error plays a bigger role. Random things can influence it more. So you want more items. Okay, a similar one, split half reliability. So as the name indicates, cut the test down the middle, assign to 2 halves, look at how much those halves correlate with each other. Just as a funny aside about split half reliability, another prof in this in the department, someone submitted a paper to her that had a long section about different types of reliability. And the student wrote it as split half test reliability, and that appeared a few times. She accidentally, with control replace, changed every instance of the word test to the word testy. So split half testy reliability. So, oops. So be careful when writing your papers.
Or you'll become a professor's story.
Or you'll become a professor's story. That's the risk. An anonymous story, but a story nonetheless. Okay. Next is inter-rater reliability, sometimes called inter-judge reliability. This is about the extent to which 2 different administrators of, or givers, whatever, 2 different people giving the test get the same results. So in the case of an IQ test, it has to be administered one-on-one. And if the test is reliable, people should get the same score regardless of which psychologist administers the test. If you get wildly different IQ scores depending on who administers it, that probably means, or at least one thing that could be going on is the instructions aren't clear enough, right? That would be a problem with the test. If it's very vague, it will be more dependent on idiosyncrasies of the people giving the test or administering the test. Similarly, you can think about diagnostic criteria in something like the DSM-5. You want it to be the case that 2 different clinicians would give the same diagnosis to the same person. That it's not going to be randomly different depending on who's looking at the patient. Okay. Any questions about, or any other questions about reliability? Yep.
With alternate forms reliability.
Oh, okay. Thank you. I'll make a note to remember that. So it's very similar to test-retest reliability. It's just a different form of the test. So let's say it's a test measuring your long division competence. It's basically the same test, but like different numbers or something. So pretty much the same as test-retest.
Sorry, give the definition one more time.
Yeah, so you can just write test, retest reliability, but a slightly different form of the test for the second one. Okay, so reliability is step one, and it's about, as I've been saying, consistency. But consistency alone is not enough to say that it's a good test. So the example I always use in intro, and the book has a similar example. Suppose I make a new IQ test, and this is how it works. I measure the length of your left pinky toe. And whatever the length is, that's your IQ score. Fabulous consistency, right? The reliability would be very high. Barring some sort of accident, I'll get the same test result every time. But no one's going to say that that's a good IQ test. So validity is about, is the test measuring what it's supposed to measure? Yeah.
This isn't construct validity, right? This is just
Actually, it basically is. So, annoyingly in psychology, people use the term validity in different ways. So we've talked about like internal, external. Either now or in my practice lectures, at some point we will be talking about both internal and external validity. The kind of validity here is basically construct validity. So I'm actually going to erase the reliability stuff. So the way that psychologists think about validity now is it's about whether a test measures a theoretical construct. The other forms of validity that we'll talk about, leaving aside internal and external, that's totally different, but the kinds of validity in this chapter can be indirect pieces of evidence for construct validity. The way that the book puts it is they can be part of building an argument for construct validity. I will note, a professor who's retiring this semester in this department, he argued that construct validity was too theoretical, and that we should be focusing on the other types of validity that are more well-defined. There are people in the literature who have argued that. What I'll say is, there are other types of validity that psychologists are very impressed with, but this is the one that they usually have in the back of their mind, that they're trying to get at. And I actually have a short video talking about the idea of construct validity. Okay, so now we'll go through the specific types, or specific types of validity that can be used to build a case for construct validity. The first one is face validity. This one is the most subjective, but it is important in the early stages of generating items for a test. So, in law, there's the term prima facie, which literally translates first face or first glance. That's basically what this is. Face validity is, does the test subjectively seem to measure the right thing? So when you're choosing items to put in the test, this is often where you start. You know, so again, if it's intelligence, you're trying to measure intelligence, the pinky toe test, well, that sure doesn't seem like it's measuring intelligence. Yeah.
Sorry, could you just repeat what that
Yeah, so does the test subjectively appear or seem to measure what it's supposed to measure? So, to use a good example, if I make a test and it has some math problems, some vocabulary problems, some general knowledge questions, and maybe some spatial reasoning, I haven't done any statistics yet. I don't have a rigorously developed theory, but it seems like it's measuring intelligence. So that's the first check. It's not viewed as conclusive, but it's one step in the right direction. Next, content validity. When you see the phrase content validity, you should have in parentheses before it all the content. That's sort of what this one is about. So if you want to put it briefly, is the test measuring the full range of what it's supposed to measure? The fancy way of saying it, that you don't have to say that's on the test, is the test a representative sample of the universe of content? If you want to sound really smart, that's the way you say it. But just to give some concrete examples, the tests I will give you, you want them to have content validity. So next week, there's a test that is supposed to measure your knowledge of the 4 chapters, Appendix B and 5 through 7. If all of the questions come from Appendix B, you would say, you probably wouldn't put it in this fancy of a way, you'd probably just get mad at me, but you would say, this test lacks content validity. Right? So that's the idea. It should measure the full range. So in the case of an IQ test, if it has only vocabulary items, you would say, well, there's other forms of intelligence that this test is not measuring. Okay, any questions about the first two? Don't want to leave anybody behind. So the book makes a mistake when defining the next one. So it says that predictive validity is the same as criterion validity. The right thing to say is predictive validity is one type of criterion validity. Concurrent is actually also a type of criterion validity. So criterion is an umbrella, and it includes 2 subtypes: predictive and concurrent. So criterion validity, so I'll start by just defining that, is about whether the test correlates with something that it should be correlated with. And so this is different from construct validity. Construct validity is more theoretical. Does the test get at this theoretical construct that we've defined? Criterion validity is really well defined. Does this test have a high Pearson's R correlation with some criterion that it should be correlated with? So there's the test, like an IQ test, and some kind of criterion. And the criterion is some kind of real world thing, something that it should be correlated with. Yes?
How do you know it should be?
Good, so
Like face validity?
yeah, so what it should be is going to be, in terms of either face validity, or I guess really I shouldn't put it that way, in terms of the theory. So here's a specific example. This is one of the most commonly used examples. If IQ tests are measuring intelligence, then the tests should be positively correlated with GPA. Right? If the IQ test is not correlated at all with GPA, okay, it's pretty silly to say it's measuring intelligence. Obviously, the correlation won't be 1, but it also shouldn't be 0. So grades would be an example of a criterion. It's something that it should be correlated with if the tests are really getting at intelligence. Another example, if a personality scale is measuring extroversion, it should be correlated with things like how often you go to parties. If the correlation is 0, this is clearly not a very good measure of extroversion. Or one other one, I think I return to this later, there's something called the psychopathy checklist. If you know about the psychopathy checklist revised, it should be correlated with criminal recidivism, right? With crime commission after you get let out of prison, which in fact it is. So those are some examples. If this test is measuring what we claim, it should be correlated with some kind of real world behavior. So that's criterion. What's the difference between these two? Really simple. If you measure the test and the criteria, so let's say we'll just stick with IQ and GPA. Correlation's about 0.5 or whatever that's worth. If you measure these two things at the same time, concurrent. If you measure this one first and this one in the future, then it's predictive. Pretty simple. So if you measure the test first and the criterion, like GPA, in the future, then it's predictive. So let's say this class. Obviously I won't do this, but if I gave everyone here an IQ test right now, and then asked what your GPA is, and looked for a correlation, that would be concurrent validity. Right, just think current, right? I'm measuring both things in the present. If I measure your IQ now, and measure your GPA 3 years down the road, then it's predictive. I'm looking for whether the test can predict something, like in the future.
So for concurrent validity, you would say if you measure a test and it's
The thing it's supposed to be correlated with at the same time.
So if we're taking the test measure and the criterion at the same time, it's concurrent,
Yes,
but if you do the criterion at a later time, it's predictive.
exactly. Yep. So if you didn't hear it, yeah, if you measure the test and the thing it's supposed to be correlated with, the criterion, at the same time, then it's concurrent validity. If you're measuring the criterion at a future time, like after you measured the test, then it's predictive. In my experience, this type of validity is the one that psychologists are most impressed with. Even if what they really ultimately care about is construct validity, criterion validity is the one that you brag about. Like if your test has good criterion validity, that's viewed as more impressive. So one example, just to give an example from my own field. So a lot of my work in grad school was done on moral psychology, so measuring people's moral intuitions or moral judgments. So I'm just going to rate. Any questions about the types of validity before I erase it and give this example? So I mentioned in passing in the research ethics chapter the idea of utilitarianism. So utilitarianism is the perspective that you morally should do whatever maximizes happiness, right? Whatever creates the greatest happiness for the greatest number, that's what you morally should do. So, well, actually, so there are different ways to measure sort of how utilitarian people are. So the construct, if you like, is how utilitarian people are. So where should I put? So since we're treating this as a construct, we're treating this as a tendency that people have. And one way of giving an operational definition of that is to give people trolley problems. And you hope that this gets at people's utilitarian tendencies. So how many of you have heard of trolley problems? They're all over the internet now, so most of you. So if you haven't, so these are cases where a trolley is going to hit 5 people, and there's different versions. In one version, it's should you pull a switch to redirect the trolley so it hits one person? So there's a dude here, and he has access to the switch. In another version, it's should you push a large man in front of the trolley to save 5? Like he's leaning precariously over the edge of a footbridge and just needs a little push. And you're supposed to imagine that you're a trolley expert and you know that he's heavy enough to stop the trolley. Show of hands, how many of you think it's moral to pull the switch? So redirect it to hit 1 instead of 5, show of hands. Okay, who thinks it's moral to push the large man? 3 people, okay, so normally I give the switch one before the large man. I may have biased you against it by doing them both at the same time. So most people, if they're hearing it for the first time, will say it's okay to pull the switch but not push the large man. Okay, this video I'm going to show does not help with construct validity, but it's just very funny. These are 2 of my favorite clips to show. They're only a minute each. A professor gave the trolley problem to his 2 kids. He had a son and a daughter. They gave different answers. Let's see if you can spot the difference.
Except
Okay,
for that would be
so-
both of my children.
Yeah. I once gave a talk on this at the U of A. I was talking about my preliminary results, and one professor, male professor, was like, "That's my boy." So now let's look at this. So the footbridge version, where the question is, should you push the large man? Ones like this were more commonly used in the literature because they sort of make the dilemma more forceful. So you give people batteries of items like this, where the question is, should you harm someone to save many? And this is used as kind of a measure of people's utilitarian tendencies. Now, what many people argued in the literature is that this is not a good measure of people's utilitarian tendencies. What many people argued is, what this is actually getting at is not how utilitarian you are, but how little aversion you have to physically hurting people. And part of what people used was criterion validity. So they would say, show evidence that people who endorse pushing the large man are more psychopathic, more selfish, various other things that don't really seem like utilitarian-ish. So like, for example, they are less likely to say it's good to give to charity and things like that. But if you're a utilitarian, or if you have utilitarian tendencies, you should believe in things like giving to charity and helping the poor. So the argument that some people made was, this is actually basically measuring how psychopathic you are. And I'll show a video, or not a video, just audio from a very good podcast. Have I plugged Very Bad Wizards yet?
No.
I usually do at some point. So it's a great podcast. Their older episodes are a bit better. Eventually podcasts run out of ideas. It has a philosopher and a psychologist, and they talk about issues that many of you may find interesting. It's sort of like just 2 bros like talking about science. So they sometimes go a bit off the rails. Note in this, at the time of this podcast, one of them was visiting Canada. They're both Americans. So we'll watch this. It's relevant to some of the issues that we're talking about. I'll stop it there. So some of you are probably repulsed by the podcast now, but a few of you, I think, will see that as a good advertisement. So just to link it back to the idea of validity, so the fact that these dilemmas are correlated strongly with these other bad traits is used by people like Dave Pizarro to argue that these are actually not measuring utilitarian tendencies. Now, I'll just say in passing, obviously not testable, but there is a technique that was developed a while after that, actually after that podcast, called process dissociation. The technique already existed, but it was applied to these kinds of dilemmas to extract a measure of utilitarian tendencies and to control for how little people care about harming people. Okay, so this is not testable. The process dissociation thing, if you're interested, I just say this because my dissertation was applying this technique to self-sacrificial dilemmas. But this part is not testable. That's just if you're a nerd like me. So it's a way of separating processes that cause a judgment, if you want a definition of it. But that bit's not testable, just if you're interested. Okay. So two. Yep. Oh, yeah.
Does that relate to conversion validity
No.
with the trolley problem thing? Because it measures different.
So good. So I'll go right to convergent validity. So convergent validity is where you have two tests that are supposed to measure the same thing. So like two IQ tests, or maybe like an IQ test and an SAT test. Like they're measuring pretty similar things. And the idea is, yeah, they should be strongly correlated if they're in fact measuring the same thing. I guess you could apply it to this case, but
That's criterion validity, isn't
no. So here's the part that's potentially confusing. Criterion validity is there's a test, like an IQ. So here, so for criterion, it's does the IQ test correlate with something like grades? Convergent would be something like, does IQ 1, let's say maybe the WAIS, correlate with another IQ test? Maybe the Stanford Binet.
Okay, so to say criterion validity should, does the test correlate with something that it should be correlating with that is not a test?
Yeah, that's fair. So some kind of behavior or some kind of other thing.
Some like real life.
Some real life behavior, or it could, there's some gray area, but if you want to say a real world behavior, that'll help you keep it clear.
Okay.
With convergent, it's two tests that are supposed to measure the same thing. Yep.
Would this be useful if you have an already established test and then you want to see if another test you just invented?
Exactly. So that often where it's used is, yeah, like you want to develop a new IQ test, you're not sure if it's any good. Well, we already have well-validated tests. Let's see if your new test correlates with the old ones. Yeah.
The example that I was doing for criterion validity is like if you've made a test for depression, you've got a bunch of people who are already been diagnosed with major depressive disorder and they get. If it says they have depression, then you have criterion.
That was used for criteria.
Is that criterion?
That's closer to convergence, I think.
Convergence?
So look, there is some gray area between them. Because so one thing you could say is, okay, let's say it's an IQ test and an SAT test. Is that the same, measuring the same thing? Maybe. Your example, because they've already been diagnosed with a previous test, I would assume.
Yeah.
So I would be inclined to call that convergence. Yeah.
So
Yeah.
one more question.
No, of course.
So for the criterion validity, would it be safe to say that it has to, the test has to correlate with something that supposedly measures the concept?
I wouldn't say like I would say like correlates with something that it should be correlated with if this test is measuring the right thing.
Okay, so humor me/us here. If we're looking at concurrent validity, if you were to be measuring,
So concurrence type of criteria. Do you mean convergent?
no. Under the umbrella of criterion
Yep.
validity, you have concurrent
Yep.
validity. So if you were to be attempting to measure concurrent validity, you measure a test and the thing it's supposed to be correlated with at the same time. It's concurrent. If you're attempting to measure intelligence, what is the second thing if not another test?
So it could be grades, people have used income, people have used how quickly you learn something on a job site. So for criterion, yeah, I like the way you said earlier, we'll say for our purposes, something that's not a test, or at least not another IQ test. If you want a sharp divide, that's the easiest way to do it. For criterion validity, it's does the test correlate with something that's not another IQ test?
Okay, so again, just for my sanity on the concurrent validity thing, how are you supposed to measure grades at the same time you're measuring IQ?
You just ask people to report it, or you collect it at the same time.
Okay,
Like if I do it right now, I give you all an IQ test. What's your GPA? Or I look it up, put them, and then I do the thing in SPSS. If I measure IQ now, measure GPA in 3 years, then it's predictive. Yep.
What happens is like I did maybe it was a scam IQ test. I don't know. I just
It was
did
online.
on
It probably was.
Yeah, and like they definitely do not correlate for me. Like I've taken IQ tests like a few times in my life, and it's like actually saying that it's like dangerously low, like to the point of it being.
Oh yeah,
like,
sure. So,
yeah. But
and
my
you're saying you have a high GPA.
is
Oh, of
very
course.
high.
I mean,
Yeah.
the correlation is not 1. So.
So it's that happens. It's
Of course.
It's just
Yeah, so the correlation, actually, here, this is, I wasn't planning on showing this, but here, just so no one freaks out or no one imbues IQ tests with more, I was actually just lecturing on this earlier in the week. Here's some real data. So I use this in 1200. This is some real data. So the correlation is usually around 0.5 is what you find between IQ and grades. Here's what that actually looks like. This is a small sample, but it's the same pattern you usually find. That's what a correlation of 0.5 looks like. So this is IQ, this is GPA. Now, clearly it's a positive correlation, but you don't have to be a statistician to notice that, well, there's quite a bit of randomness there. So obviously other variables are at play, other than measured IQ. Some of that could be owing to measurement error in the tests, and also could be owing to the fact that variables other than IQ influence how well you do in school, obviously. Right? So there's people with lower IQs that still have high GPAs. Right? Because remember, this is psychology. Correlations are they're never 1, and usually not even close. Yep.
so if you want concurrent validity, you would need to have a decent sample size?
No. I mean, bigger sample size is always better, but you could measure concurrent validity with a sample size of 20. People just won't, be super impressed with it. Yep. I didn't know this would be such a popular topic. I thought, okay, yeah.
Do you know of any tests that measure different kinds of intelligence? Because normally it's like psychology, it's only been analytical.
Oh, so no, I mean, like the standard, I shouldn't have closed the PowerPoint, but like for the WAIS, there's 4 main, I think they're called index scales, each of which has many subtests, and most of them are not verbal. So there's one called like the verbal reasoning index, and that has kind of the stuff you'd expect, like vocabulary, general knowledge, and stuff like that. One of them is just perceptual reasoning. English doesn't have to be your first language, it's just like kind of visual puzzle solving. So no, now what they don't include is many of what Gardner called intelligence, like musical intelligence or stuff like that. So it's mainly like verbal stuff, math stuff, and spatial stuff is what kind of standard IQ tests have. Yep.
I just want to know, like, okay, so you've seen IQ tests, right? So
Yeah.
like the one that I just want to know if it was a scam or not, because the one that I did, it was literally just like a bunch of weird images and like puzzle type things, but
Yeah.
no other forms of testing at all.
Yeah,
and
so-
I just had no idea what they were.
Was it when you did
That might have been Raven then.
Yeah, I was gonna say Ravens probably. So like,
Okay.
was this one that a professional gave you, or was it like when you did it
No,
online?
It's online.
If it's online, like never take seriously what an online test gives you. Now, it's true often that if someone's crunched for time, they'll give the Ravens progressive matrices, which is kind of a visual type IQ test. The reason it's used often is among all the IQ tests, it's one of the most G-loaded, which means basically if you can only give one test, it's a pretty good one because it's correlated with the others more strongly, but it's still, it's not as good as getting the full scale. And I can see in your face, and I see it in people all the time, people really worrying about, oh, is my IQ this or this? You should spend 0 time worrying about that. Like if you have a good GPA and you're doing well, like IQ, I don't think anyone should ever know their IQ. I think there's 0 value in you knowing yours. It is correlated with these things. So it's good if you're trying to predict things, with
Health,
samples.
lifespan.
Yeah, exactly. But for you as an individual, it's like, okay, I think it's of almost no value.
The reason why you're getting so many questions about validity is because I've read 3 different textbooks
Yeah.
and 3 different definitions of what all these different kinds of validity is.
No, I mean that's true.
Yeah,
So
I'm in 3 different classes, and all of them have different definitions for
Yeah,
all
so
of these different kinds
That's
of.
why
one of my old professors would feel very vindicated because he would kind of complain about the confusions in this area. I'll just say, I'm the one marking the tests, whether I have the right definitions or not. Just go with kind of the ones I've given if they show up on the test.
That's why we're asking all these clarifying questions.
Yeah,
because
no,
we
it's
have
totally
so many
fine.
different-
I encourage questions, so that's fine.
Yeah.
Okay, there's only one more. We'll see how much of a problem that one adds. The last one is discriminant validity. And here, actually, I can imagine some ways in which other classes might define this one differently too. So maybe there'll be some more questions. This means a test should not correlate with something that it shouldn't be correlated with.
Okay.
Now,
is
here's
that a test or is that a real world thing?
typically it's used for another test.
Okay, with another test. Thank you.
Now, the thing that some books leave out that's really important, when I say not correlated with, usually what's meant, and what people should mean by that, is less than a certain amount. It doesn't mean not correlated at all. Again, a conventional cutoff is something like 0.7 to 0.8. If it's above that, if it correlates with another test more than 0.7 or 0.8, then we would say it's basically measuring the same thing. And just before I get to the hands, just to give an example, or actually, I'll go with hands. Yeah, go ahead.
Repeat the definition one more time.
Yeah.
Yeah, so it should I'll say it this way, not correlate strongly with something that it shouldn't be correlated with strongly. So that all sounds very abstract. I'll make this really concrete. So this is something that I used, again, in my dissertation, the cognitive reflection test. So this is a test that's supposed to measure how much people tend to correct their intuitions. So we have intuitive responses. This test is supposed to measure how much we check our own intuitions. So here's a famous item. Some of you may have seen this. A ball and a bat are $1.10. So the ball and bat together are $1.10. The bat is $1 more than the ball on its own. How much does the ball cost?
10 cents.
Yes. So, well, no, but yes, that's the answer that pops into people's heads. So, the answer that pops into people's heads, the intuitive answer, which I had when I first saw this, is 10 cents. But when you pause and reflect on that, you realize that can't be right. Because if the bat is $1 more, then the bat is $1.10. $1.10 plus 10 cents is $1.20. So then you have to pause and go, wait, shit, maybe do it by hand. And if you spend time with it, the answer is actually 5 cents. The ball is 5 cents. So you give a number of items like this where there's an answer that pops into your head that's actually wrong, that you have to. And the more people get them right, we take that to mean they're more reflective. They're more willing to correct their or check their intuitions. But one thing that people have brought up as a criticism is maybe this is just measuring math ability. And we don't want it to be measuring that. We want it to be measuring how much do people correct intuition. And one key thing is, how strongly does it correlate with things that just measure math, that have no intuitive versus reflective thing? And if the correlation is like 0.9, you would say, okay, this is just measuring math. It's not measuring anything separate from math. I'm of the view it does measure something different, but just conceptually that's what it would mean. If the correlation is more than something like 0.7, 0.8, we would say it's just measuring the same thing. Yeah.
I feel like you could always find something that will correlate to whatever you're trying to measure at 0.7, 0.8. So does it need to be like something specific? Like you said, now you're like,
Oh, I would say
I'll
it's,
check math.
I'm inclined to say it's not so easy to find things that correlate 0.7, 0.8.
And if you look through enough things, you know.
I guess so. I'd be inclined to say at that point it's probably not going to be something replicable. Like there's the kind of the p-hacking thing you can get,
Okay,
but
so you're saying it's replicable. Like
yeah,
it needs to
a real
reliably correlate.
exactly reliably correlates with it. Now again, going back to the professor who is critical of a lot of this stuff, there are people who argue this shouldn't be relevant to how we define the variables. But as far as how psychologists practice, if the correlation is large enough, we tend to say it measures the same thing. And the extent to which it doesn't correlate that much with other things, we say it has discriminant validity. So just before the hand, in this case, if this is at least somewhat uncorrelated with math ability, that gives us more reason to think this is something different. It's not just math, it's measuring something like how much do we correct our intuitions. Yeah.
So just for my own sanity here, doesn't depression and anxiety basically, aren't they almost interchangeable on almost every test? I'm not saying that people with depression always have anxiety and people with anxiety always have depression. But everyone I know who has depression has anxiety, and everyone I know who has anxiety has depression.
I have to look at the number. I don't think it's in the 0.9 or 0.8 level, like above this.
Okay.
I have to double check. But here's one thing you're totally allowed to say. Let's say the correlation turned out to be 0.95. You could say, wait, but aren't they still conceptually different things? And what you'd be saying then is, we shouldn't use discriminant validity to define the different constructs. And look, I was saying to someone in office hours today, I'm not a preacher. I don't try to convert people to believe things. When you go to home at night, you can believe whatever you want. And if you do your own research, you can use different assumptions. All you have to do in a course like this is understand the different perspectives and the different terms. So you can decide, you know what, discriminant validity is bullshit. We shouldn't use it, and it's a free country.
I was going to say in a different course, they said it's 50% of people who have depression have anxiety. Most people have anxiety have depression, so it's not 100%.
Good. So that's I guess good for the pro discriminant validity people. The correlation's not high enough to say that they're the same thing. Yeah.
Does discriminant validity also mean that a test should be correlated with something it should be correlated?
No, that's convergent.
That's convergent.
Yeah. Discriminant means like being able to tell the difference between things. So that's the idea. That the test discriminates. It's getting at something different. Okay. That's the end of the validity stuff.
For now.
Well, there are, yeah, so actually I'll just say, just for whatever it's worth, just to eliminate confusion, the other two types of validity that come at other points have nothing to do with measurement, with does the test measure the right thing or not measure the right thing, which are internal and external. If I was the dictator of psychology, I would have just made different words for those two things, but alas,
Just makes me wonder if there's a lot of validity within psychology's definitions.
that's too meta for me, even for me, and I'm a philosopher. Okay,
I
so
would argue not.
okay. On that note, the next term, we're almost at the end of the chapter, is participant reactivity. I'll just do this quickly. People behave differently when they know they're being observed or measured. There you go. People behave differently when they know they're being observed or measured. Okay. 4 terms left in the chapter. They're all related. You may have seen this, you would have seen it if you took 2300, for example, the 4 different types of scales. So the scales are as follows: nominal, ordinal, interval, and I heard someone say it, ratio. How many of you have seen these at some point? Okay, good. It's actually a majority. Good. So the way to think about it is the way I wrote them. As they go down, they increase in mathiness, to use a very technical term. More mathiness the further down you go. So nominal, no mathematical content. Ratio, you can have the most mathematical fun with. So nominal just means name. So gender. You label your people as 1 and 2, 1 male, 2 female. That doesn't mean females are twice as gendered as males. Or it's just, you could have easily done it the other way around. So ethnicity, gender.
Categories?
Sorry?
Categories?
Yeah, categories where there's no mathematical content. Sorry?
No, it's the same thing.
Okay, yeah. So that's nominal. So ordinal, you get a little more mathiness. You get the greater than, less than relation. And after nominal, as you move up, you keep the things that the prior ones had. You just get extra things. So ordinal, the new thing you get is the greater than, less than relation. So here's an example. Let's say I rank ordered everyone in this class in terms of their grade in this course, out of 100. And then I gave everyone a number from 1 to 30. So there is mathematical content now, but the intervals between the people are not necessarily the same, right? The gap between 1 and 2 might be 100% versus 90%. And the gap between 2 and 3 might be 90, 89. So what ordinal is missing is equal intervals. You just know that one is higher or lower, but you don't know how much higher or lower. Yep.
Have we done discrete versus continuous? I missed today.
Yeah, so no, we're discrete and continuous aren't, at least not in this chapter. So don't worry about that yet.
Okay, well, no, that's just the easiest way to separate these.
So continuous is these two.
Yes,
So these two are the continuous ones,
Yes.
interval and ratio.
yes, and then the other two are the discrete.
Yes.
That's
But
what
there's-
I'm saying.
But so if you want to add that, it's fine. But if it's not in the key terms, don't worry about it. Yep.
Is ordinal can still be categorical data? Because you're just ranking it, right? Or-
Yeah. So ordinal would still be categorical in that sense. Yeah.
And it can also be numerical, just, there's no.
There's not equal intervals, but there is a greater than, less than relation, which nominal doesn't have, right?
Yeah.
Insert joke here about whichever gender you're on. No, we are better, but there's no, jokes aside, there's no greater than, less than.
The ordinal has no zero, right?
The next one's the one that doesn't have a zero.
What?
So, the next one, interval. Well, it has a
I
zero,
was
but
about
not
to say, interval absolutely has a zero.
but not a real zero. Is where the zero does not mean an absence of the thing. So what interval gains over ordinal is, as the name suggests, equal intervals. The gaps between the numbers are the same size. So the difference between 2 and 3 is the same as the difference between 3 and 4. That's what it gains over the ordinal scale.
As fake zero.
Yes. Yep.
So are you saying that for the interval scale, that everything's the same?
The gaps between
The
them.
gaps, okay.
Yeah, exactly. So, but what it doesn't have, that ratio does, is a true zero, where zero is the absence of something. So, one example is temperature, unless it's Kelvin. So, for Celsius, 0 degrees Celsius is the freezing point of water. It doesn't mean the absence of temperature. So temperature is molecular motion. It's like how fast the atoms are vibrating, basically. Insert more physics here, but for our purposes, that's what it is. 0 degrees Celsius doesn't mean there's no temperature. It's just it's just the freezing point of water. The same is true for IQ scores. Not all IQ tests go up down to 0, but if they do, it doesn't mean 0 is the absence of intelligence. It just means you're a certain number of standard deviations below the mean.
It's possible to get a negative intelligence score.
You could design an IQ test that way. I'm not sure if any of them go that low, but theoretically, it's just how many standard deviations away from the mean you are. So you have to be quite a few, but theoretically, you could make an IQ test like that. I don't know if the ones that exist have enough items to get you a score that low. Yep.
So that means that it's impossible to have an absence of intelligence.
Oh, it's definitely possible. Just look in the U.S. No. But at least a 0 IQ score doesn't mean the absence of intelligence. I mean, joke aside, if you're dead, you don't have intelligence.
Yeah.
But at least with the IQ test, a score of 0 doesn't mean the absence of intelligence.
Arguably, animals are very intelligent. However, they do not have IQ scores.
Yeah, exactly.
Maybe we need to do a dog IQ test.
There are.
Yeah. So then, the final step, with ratio, you do have a 0 that means the absence of a thing. So, something like height. If you are 0 inches tall, you don't exist, right? Like 0 inches is the absence of height. For temperature, Kelvin is like that. So if you're a nerd, you might know this. 0 Kelvin means the atoms are not moving perfectly still. It's like minus 400 degrees Celsius or something like that. So Kelvin would be a ratio scale. The reason it's called ratio is you can form ratios between the numbers. You can say that, something being 50 inches high, that means it's half as tall as something 100 inches high. That's not true with IQ scores. 140 is not twice as intelligent as 70. You can't do those ratios because there's no true 0. Okay, any other questions about the scales? Okay, so that's the end of the measurement chapter. The next chapter is on the distinction between qualitative and quantitative. Most of it is on qualitative research. But that's probably a natural place for a break. The next chapter is pretty short, so we'll do that, and then whatever time is left, we'll go through SPSS again. So let's take 15. We'll come back at 5:10. Okay, everybody, let's get back into it. Hey, you can go outside if you want. I can't force you to stay here. Okay, so someone came up to me during the break and said they weren't expecting to be called a psychopath because they were someone who said. Now, I will just note 2 things. Number 1, I'm not a dyed-in-the-wool utilitarian, but I definitely lean that way. I have kind of my own view, but I definitely lean utilitarian if anything. So I'm insulting myself too. But I'll add something to make those of us who lean utilitarian feel better. We do also score on average higher on the cognitive reflection test. So that makes you feel better. So at least you're a smart psychopath.
Less likely to be caught.
Yeah, exactly. There you go. Perfect. And of course, also, all these things are on average, so I'm not attributing anything to everyone specifically. Okay, so now we'll do chapter 7, which should take less time, and then with whatever time's left, we'll do SPSS. So, broadly speaking, there are 2 ways of gathering data, qualitative and quantitative. So some of you had issues with definitions in the last chapter, and I'll, of course, encourage questions to make sure we're clear. We'll keep it simple. Quantitative, there are numbers. Qualitative, there aren't. At least to a first approximation, that's good enough. Yep.
On the test, we just put there are numbers and there are not numbers.
Yeah, exactly.
We would get
Maybe like
points.
a form of research in which there are
Okay.
numbers, or in which there are
Just one word, numbers.
not. That's maybe pushing it a little bit. Yeah. So the way you would gather qualitative data typically is some kind of interview, right? You talk to people, you look at the body of what they say. There's different ways of doing this, but broadly speaking, you're going to be trying to extract themes or patterns in what they say.
So like interviews and.
Yeah, so interviews is a standard, probably the most common kind of qualitative method. Yeah.
Surveys?
So surveys, but where it's like a free answer, not like a scale. So if it's
Got
a
it.
scale of some kind, then it's quantitative.
Copy.
So just for whatever it's worth, about 5 years ago, there was a meta-analysis looking at psych journals. Around 90% of papers in psychology are quantitative. Around 5% are qualitative. And then around 5% are mixed or other. So I'll note up front, this will come up a few times over the course of this chapter. I am not an expert in qualitative methods. I was never trained in the use of qualitative methods. I am skeptical of some of the practices and assumptions of the qualitative researchers, and I may note that at various points, but take everything I say with a grain of salt because this is not something I was formally
Be skeptical
trained in.
of your skepticism.
Sorry?
Be skeptic of
Yeah,
your
skeptical.
skepticism.
I won't call myself a critic. And yes, you can be, as she says, skeptical of my skepticism. That is totally fine. Okay, so typically, as I say, it involves an interview, standardly of one person. If you're doing what's called a focus group, then you're interviewing more than one person. The book defines it as 6 to 10 people. You know, that's kind of, I'm not going to be that picky if it shows up on the test, but it's a qualitative interview of multiple people, right? A group of people. The term transcription just means, you know, it's like an audio recording of the interview. You have to make it into text. You have various decisions to make, such as whether you include body language, if it's a video recording, you know, do you include the ums, ahs, and pauses? I'll talk a bit more about that later. I'll say more about this later, but there are mixed methods approaches, so you can combine quantitative and qualitative data in various ways. Increasingly, you can get computers to analyze qualitative data. So natural language processing, this is the use of software to organize and analyze qualitative data. So you can unleash an algorithm onto the set of interviews that you did.
You said for qualitative.
This is for qualitative, yeah. So you have some kind of interview, and you know what the natural language processing might do is, you know, uncover emotional themes or, you know, tendencies in the text, not necessarily a number. And then the term corpus is just the body of texts that's fed into the natural language processing. So the fancy term for the ums, ahs, and other things like that is disfluencies. So fluent speech means continuous speech, like I'm engaged in now, mostly. if there are ums, ahs, and pauses, those are disfluencies. And these can convey information, right? So suppose someone asks you about this course and how I teach this course. Someone asks you, how is such and such as an instructor? Are they a good instructor? And so in one case they say, yes. In the other case they say, yes. That's relevant. You may, okay, I'm not so sure I'm as confident in the second response. So pauses may contain important information. One way of getting towards doing mixed methods is having a coding scheme. So a coding scheme is one way of getting quantitative information out of qualitative data. So you may just be doing qualitative type research where you do interviews, where it's long form, open-ended. But then once you have the interviews, you may count things like how many times do they use a certain word, or how many times does a certain theme come up. And a coding scheme is just a rule or a set of rules for counting things in the text or in the transcript. So you interview everyone here about this course. How many times do they use the word angry? When they talk about this course, or how many times do they use the word bored? And then you can do standard statistics with that once you have the numbers. Yep.
Wouldn't that be just considered quantitative then? Like if you're converting something to an operational variable?
Yeah, at that point it is. I guess it starts off as qualitative as far as how you're gathering the data, but then once you turn it into a number, now it's quantitative.
But he did say this was a mixed method, eh?
So coding scheme is one way of turning it into mixed methods. Yeah. Okay, so this is going faster than I thought. As is clear, I don't have much to say about this chapter. So on that skeptical note, though, the next term is reflexivity, which is where the researcher acknowledges their biases or their perspectives. Yeah, so where the researcher acknowledges their biases or their subjectivity. Now, you might think, oh, that's so they can control for it or try to reduce their bias. But as far as I can tell, as an outsider, no, subjectivity is embraced in qualitative analysis, at least as standardly done. So this is where skeptics like me say, well, wait, one of the scientific ideals is objectivity, or the term the book uses, disinterestedness. You're supposed to aim at being as impartial or objective as possible. And just to give a quote, so I wanted to confirm this. Here's an influential journal article defending the qualitative approach. We no longer seek to eradicate the researcher's presence. Subjectivity in research is transformed from a problem to an opportunity. So I'm not thrilled about that. Now, one thing that qualitative people, at least when I've talked to them or when I've seen them defend it, they'll often say, well, it's not possible for us to be perfectly objective, which is of course true, but what I would say is that's true of basically every ideal, right? So you could say, well, the one ideal I would defend is, be compassionate. And someone could say, well, it's not possible to be perfectly compassionate, which is of course true, but the solution to that is not, well, let's throw out the ideal. It's, well, let's try our best. And this, I would say the same about being objective or disinterested. Of course, it's not possible to be 100% objective, but the goal should be to control for bias or subjectivity. So, yeah, I saw two. Yep.
I don't know, what you would think of this, just to make a case, although I don't know where I stand.
Oh no,
Yeah.
I did a degree in philosophy. You know, playing devil's advocate or all that is, yeah, of course.
But I feel like what a proponent would say is that they're not necessarily, the point isn't to be as objective as possible. Maybe you're saying from a research perspective, one of the goals is objectivity. However, there are facts of the world in which there is subjectivity introduced. Now, an objective approach that's just purely quantitative may miss those because of its focus on disinterestedness. However, a qualitative approach would catch those facts, the interaction between the subjective, I don't know what you would call it.
Good. So so none of what I'm about to say is testable or anything you have to worry about. What I'd be inclined to say is, look, subjectivity is part of the world. Human beings are subjective. What I would object to is the researcher and embracing their own subjectivity. It's perfectly fine to analyze people's biases. Like, you know, everyone in this room, everyone has biases and subjectivity. If I'm studying you, I should be trying to be objective and just figure out what's true in the world, including what's true about people's biases. What I think is illegitimate is saying, I'm biased, I have subjectivity, and I'm going to embrace that as I do my research, if that makes sense. But it's an interesting objection. Yep.
I think it's kind of similar, but I'm curious if it's embracing it or just codifying it, just saying, you know, no one is as like objective, so I'm gonna just say that, you know, I'm gonna look for my subjective experience and put it on paper versus not putting it on paper and just
Good. So that's a more charitable interpretation. So, and again, from the outside, that's what I initially thought it was. And if it's just that, if it's just I acknowledge and admit I have this bias, that's great. Like people should do that more. The quote I read where it's transformed from a problem into an opportunity, that's what makes me uncomfortable. That to me sounds like embracing one's own bias and subjectivity. Acknowledging it, that I think is fine. What I would say is the goal should be to try to reduce it. Like, yes, I have this bias, I'm going to do my best to reduce its influence. And I get the sense that often that's not what they're doing. But maybe I'm wrong. But okay, but none of my rant is testable, of course. Okay, so the book goes through a number of different specific types of qualitative analysis. We're just going to focus on one. I'm not going to test you on all of them. I'll show a video of describing one of them. So the one I'm going to talk a bit about is thematic analysis. So some related terms here. So the book talks about this. There are codes, like maybe a coding scheme. So those are kind of the small units. And then the bigger unit will be a theme. So for example, let's say you're interviewing people who have depression. One code might be work-related problems. So every time they talk about their fear of getting fired or their fights with their boss, okay, we'll call that work-related problems. Another code might be relationship problems. So every time they say, you know, I keep fighting with my girlfriend, or I'm afraid she's going to leave me, you know, whatever, you know, we'll call that relationship problems. You know, or maybe something like, I just know that I'll never be with anyone. You know, whatever your thing is. And then if there's something that the codes have in common, like, so maybe both in work and in the relationship stuff, there's hopelessness. Okay, hopelessness would be a theme. It's something that you can find in multiple codes. So I'll show a video to fill that in a bit more. Okay, I'll stop it there. So the details of the software obviously is not testable, but I wanted you to hear from someone who actually knows how to do it in practice. So I was going to have us do an activity where we interviewed each other, but I'll save time for doing SPSS at the end. So, but just so you can see what it would have looked like, I actually stole this from Nina Di Pietro. So this would be a perfectly valid qualitative analysis. You could imagine doing this. You interview people about their experiences at Douglas, and then you would apply this, right? You extract codes, and then use those to extract common themes.
You make the text a lot bigger.
Oh, sorry. So, yeah, I'm not going to test you on that. That's just something we would have done if we had finished all the SPSS stuff last week. Okay, so just 2 terms left. Oh, yeah.
Just to sort of sum up thematic analysis from what you know, what I got is it's essentially you have like a bunch of interviews on whatever your topic is.
Yeah.
You take excerpts and you do sort of a literary analysis like you would with like a book, just with the interviews, and then write an argumentative essay about your hypothesis essentially?
Yeah, so at the end you'll argue, you extract those codes, you have, some themes, and then you'll make an argument from that. Okay, so for example, it seems like professors have a big effect on student experience, based on different things you extract. Okay, so the last 2 terms are inductive and deductive. So the book defines deductive and inductive in a way that I would complain about if it was a philosophy class, but we'll stick with what the book says just to avoid confusion. They define it in a way that psych textbooks often do, but I'll go along with it. So it's defining these 2 in terms of the relationship between theory and data. Inductive is more bottom up. You start with the data, look at your data and try to build a theory, or in the case of qualitative, build themes or things like that out of the data. So it's from data to theory. Whereas deductive is top down. You start with a theory or with a hypothesis or an assumption, and you use that to guide how you analyze the data.
That's deductive?
That's deductive, at least in this sense. I'd be pickier if it was a philosophy
Deductive
class.
is you start with the theory.
Sorry?
Deductive is you start with the
Yes.
theory. And then inductive is you just start with the data set.
Yeah, start with the data. If you like, you let the data speak for itself is inductive. So, like if we did the Douglas activity that I was gonna do, so where you all asked each other about your good and bad experiences at Douglas, maybe when I analyze the data, if I'm doing qualitative, I might say, I think that professors have a very important role in shaping student experiences, and let that kind of guide what I focus on. Then I'd be doing deductive. I'm sort of starting with my theory or my guess and letting it guide how I analyze the data. Yeah.
Could you go over from Appendix B to Chapter 7, which are not going to be on the test?
Not off the top of my head. If you have a question about a specific one, you can let me know. Yeah, I think in passing I may have said a few times, oh, not this, but I don't have like a ready-made list in my head of which ones to not worry about. I mean, the most important thing is let the key terms guide what you focus on. And in a second, I'll actually say, again, what the written are, so those are obviously ones you're going to want to focus on. But any questions on these before I talk about the test? Okay, so, yep.
Sorry, right before you move on, just a quick question about inductive reasoning. So inductive reasoning in this sense would usually be done on like secondary data analysis, right?
It doesn't matter, it can be primary, secondary.
How would you go about that though? Because you're supposed to form your hypothesis before you do any kind
Good,
of testing,
so
correct?
yeah, so especially with quantitative data post-replication crisis, yes, you're supposed to have a hypothesis in advance. Now, some people still do exploratory data analyses without a hypothesis, and then it would be more inductive. And this chapter is mainly about qualitative, so with qualitative it's even easier to see how inductive would work. Okay, so as I said at the beginning of class, next week is test 2. They always have the same format, 9 definition questions, each worth 1 point, 2 written, each worth 3. The week after that, your paper draft is due. So upload it to Blackboard and email it to your partner, and that's due 1 minute before class begins. Don't play with fate. Upload early to avoid having a technical issue. Okay, 2 written. The first one connects to the replication crisis. The 3 The 3 terms that will be covered in the first written will be p-hacking, the replication crisis, and how pre-registration is a solution, at least a partial solution. Yeah, for sure. P-hacking, replication crisis, and pre-registration.
And these are just like easy questions.
Yeah, this is, the first question will be about those 3. Basically, it'll be like, how did p-hacking contribute to the replication crisis? And I guess you have to include then an explanation of what the replication crisis is, and how pre-registration is part of the solution. That's what's going on with the first written. It's good you guys asked lots of questions about this today. The second written will be about types of validity. Yay! You get to find out which types on the day of the test.
What?
So there you go. I don't even remember what they are, but it's types of validity.
We just gotta know all of them.
Know all those validities. Yeah. Oh, please try to contain your joy.
What is it like, what's the context of the question? Just
It'll be something like, suppose I made a new test. I'm pretty sure I say, suppose there's a new IQ test. What would these, it'll be 3. What would these 3 types of validity mean in the context of this new IQ test?
Say that again?
So like, suppose I invent a new IQ test. I'm pretty sure it's IQ test, but I'll say some new test of some psychological construct. What would these 3 types of validity mean in the context of this new IQ test? Okay, so let's do SPSS. So I should say you're all free to go. If you've already done SPSS or you are done with listening to my voice, you can watch this later. Or, as I mentioned to someone who left, you can stick around after test 2 if you want. Just remind me when you hand in your test, and I'm happy to help you then too. So, but for those of you who want to stick around and get this out of the way, we'll do this. So I explained last time how to log into Qualtrics. Okay. Okay, and also, if you haven't already, of course, also download the paper template. So I'll go ahead and do that so I can go through that. Okay, so when you get here, you can close this part. And this is what your data set should roughly look like. Okay, so, and then you should have 2 conditions like this. So the first thing to do, and some of you already done this part, but I'll just walk through everything, is take one of the independent, or one of the conditions. So I've now drawn this many, many times, but so there's your sample, randomly assigned to 2 conditions. The 2 levels, or the 2 conditions, constitute your independent variable. So like condition 1, condition 2, and then you have 2 DVs, which are measured in both people, or sorry, people in both conditions. So I'll take one condition and sort ascending or descending. So you right click, sort ascending or descending. So now everyone's like this. Then you will right click, insert variable. So it should say like variable 0001. So this will be your independent variable. What you have to do is give everyone a number. So let's say I'm going to make time 1. So just type 1, Control C, then select all, Control V. So now everyone there is 1. Same for the places condition. Control C, select all. Okay, some people here are blank. So if they're blank, they shouldn't get anything. So does that mean they probably just didn't finish or something? So we'll just do 2 for all the ones that actually have something. Okay, so just leave those blank. Now, since we have more time, I'll go ahead and do this too. Click variable view. So let me just remember. So 2 is places, 1 is time. So I'll go to variable view, find variable 1. Yep.
You do 1 and 2 in the same column.
In the same column, exactly.
Just
Because
depends on which condition it is.
exactly. So this is going to be one of the variables we need, because you need a variable where it tells you what someone is. So this is our independent variable. So it's called var001. Go over to values, and then there should be 3 dots, right? So var001, go over to values, click the 3 dots. Anyone have trouble with that?
Where is values?
It's right here. So it's called values. Go down. So where var001 and values intersect. And then we'll hit the green plus. So for value 1, that's time. That means they're in the time condition. This person's experiment, if I remember correctly, is in one case you're supposed to think about a time in your life, and the places condition you think about a place that you used to live or be or something like that. And then we'll do another plus. 2 means places. And then click OK. So now that'll make it easier later. You don't have to constantly remember what 1 and 2 mean. It'll just be there. So, oh, and also, let's go back to variable view. We'll give it a name. We'll just call it ind variable. Just to remind us that's the independent variable. Okay, so now, since this person just has 2 dependent variables, we're ready to go. Now, show of hands, how many of you have a dependent variable with multiple items? Only a handful. So if you do, go to transform. So you may not be able to do it all right now, but you're going to go transform compute variable. So this person's 2 DVs are happiness and nostalgia. Let's say we want to put them together, nostalgia, whatever. It's kind of goofy, but just so you see how to do it. Go down. So you put the name here where it says target variable. And we're going to find the 2 things. So it's how would you, whatever. Put that here. So that's happiness plus the other one, nostalgia. So you have all that. You press OK. Ta-da. And look, it should be right? So this person has 1 for happiness, 1 for nostalgia. They have a score here of 2, and so on for the other ones. So if you have to add things together, do that. Yep.
If I already got Qualtrics to add them up into a total score for that, I can just use that.
You just use that.
Right?
Yep. So let's do the correlation first because it's easier. So the last thing you're supposed to do is correlate your 2 dependent variables together. So for that, analyze, correlate, bivariate. Bivariate means 2. And then scroll down, find your 2 things. You can just do control click if you want. And put them both in here. Anybody not get to here? Yep, we'll do it again, so no problem. Analyze, correlate, bivariate. Analyze, correlate, bivariate. Anybody still not here? Okay, and then go down and find your two dependent variables. Boop. Boop. Put them both in the variables box. And then you just push OK. So in this case, they're negatively correlated, but not significant. So the two numbers, the Pearson correlation is what you'll put next to R. So it'll say R equals, and then sig to tail, that's the p-value. Yeah. And so you can do one-tailed if you made a prediction or you're making a prediction. If you're not making a prediction, you use sig two-tailed.
So sig two-tailed is the p.
Yeah, is the p. Yeah, that's the p-value. So once you have this, you'll put that in here. So in this case, happiness was not, well, there's different ways of doing it. What I would say there is, was negatively, some people would complain about me doing it this way, but I don't really care. Happiness was negatively correlated with nostalgia. So R is minus 0.228, minus 0.228, and then the p-value, as someone rightly said, is sig two-tailed, so it's 0.252. And then you have to add, this was not significant. So there's different ways of doing this, but just make sure you accurately communicate whether it's significant or not. You could also just say it was not significantly correlated with blah, 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 and then put the numbers in. That's fine too. And then you have to include a screenshot for all the stuff. So any questions about where I've gotten to so far? So I'll just do a control print screen. So that gives me a screenshot, and then control V.
You can also just copy it on SBS.
You can, but sometimes it gets goofy. You have to make sure you copy it and paste it as an image. So if I just do control V, oh, actually, that's okay, I guess. But that's fine too. Looks a little ugly, but so does this. So just make sure you paste the image somehow. Okay, any questions on reporting the correlation?
You're putting in the x values there, you're saying like this dependent variable is correlated with dependent variable?
Exactly, this is for the two dependent variables. Yeah.
Can you just show on the table once again where you find that correlation?
Yep, so the number here beside Pearson correlation, that's what you put next to R equals. That's the core. It's funny because in this case they're similar numbers, which basically you want this to be big and this to be small, right? You want you want it to be a big correlation and a small p-value. So the sig two-tailed is the p-value. So that you put next to p equals da-da-da. And if this number is less than 0.05, you will say it was, if it's less than that, you'll say it was significantly da-da-da. Yep.
I just, because you said if you had a prediction, use the one tail.
Yes.
Don't we all have predictions because of our hypothesis? Or?
If you do, use a one-tailed. Yep.
But, right?
Well, I mean, some people may not have a hypothesis. They may just think it's going to be correlated to some degree, but I don't know which way. If you have a sense, no, I think it's going to be correlated this way, then use a one-tailed. Now, I should add, if you find a correlation and it's in the opposite direction of what you predicted, then you definitely use a two-tailed.
Okay.
Yeah. But if you have a prediction, like I think it's going to be this way, then start by using a one-tailed.
Okay.
And just to add to that, just to remind you how you do that. So if you do have a prediction of which way the correlation should go, the same thing, analyze, correlate, bivariate, and then here, just click one-tailed. So let's pretend, oh yeah, I predicted it was going to be negative. So now the p-value will be half the size.
Why is that?
Just
It's
look
like,
at
just
the area.
because of a prediction, that means like I'm more correct.
No, it's well, you're sort of cheating if you use a one tail, but you weren't making a prediction. You're sort of pretending you were predicting that I knew it was going to be positive all along, but really you didn't. So you're kind of cheating.
Okay. Alright.
Yep.
Is it possible for you to just at some point after the
Yeah, after John, I'm happy to look at anyone's stuff, but just because there's only 10 minutes left and there might be another class, although hopefully not, I'll show you how to do the t-test again too. So you're going to technically do 2 t-tests because you're going to do a t-test for each of the 2 dependent variables. So the t-test is, are these 2 groups significantly different for each of the dependent variables? So analyze, compare means and proportions, independent samples t-test, grouping variable is SPSS's name for the independent variable. So I have something here called ind variable. So put that there. You have to click define groups. It always defaults to 1 and 2. So if you already named it 1 and 2, that's great. If you named it 0 and 1 or 1 and then you have to make it correct. But if you did 1 and 2, it should already be right. So just hit continue. But even if you named it 1 and 2, you still have to go through that step. You have to click define groups and continue. Is anybody not here?
Yeah.
Start over again. So just in case, yep, no worries. So just again, analyze, compare means and proportions, independent samples t-test, or whatever you named your independent variable. Put that in grouping variable. And then define groups and just whatever. So like for me, where is it? Yeah, I named it 1 and 2, so it's 1 and 2. Yep. And then take your 2 dependent variables and put them in test variables. Once they're there, click OK. Yay. So there's 2 t-tests for each of your 2 dependent variables. So just to go through what these are, so this is why it's good to name your variables, because then it'll show the names here, which makes it easier at the end. So let's just do this one. How often have you experienced feelings of nostalgia? So just for the video, the mean nostalgia for the time people is here, and the mean nostalgia for the places people in that condition is here. And then that's the standard deviation associated with each of the fields. So then, so let me just do this. One thing that makes your life easier is if you just do this. Just separate the, because then you can just, actually, it's easier to put this one to the left actually, because then you can just block off that stupid stuff. Move this over here. Okay, so let's focus on nostalgia, the second one. So the mean nostalgia, so those in the time condition had higher nostalgia scores. So the mean is 1.83, and the standard deviation is 0.577. So I got that just from here. So this is how nostalgic people are in the time condition. And that's higher than the places condition, where the mean is 1.64 and the standard deviation is 0.842. And this difference but this difference was not significant. So T, you put the degrees of freedom where it says XXX beside T. So for nostalgia, degrees of freedom is 24. Oh, and like I said, now even though here the test for equality of variances is violated, it's significant, we are assuming all variances are equal. From I decree you all have equal variances, just to keep this simple. So the t number is 0.661, so you put that here. So t brackets degrees of freedom goes here. That number you get here from df. And the t number, which goes here, is 0.661. We'll use a two-sided p-value, so 0.515. That's obviously not below 0.05. And I'm sure most of you are seeing p-values not below point. Does anyone have a significant result for the t? Nice, we have one. So just to repeat, so the one that's weird is like this. This number is degrees of freedom. So you get that from here. I can come and help you with more detail later. Okay, so then D, which is effect size, you get that from down here. So you get it from the point estimate beside Cohen's D. So how often have you experienced feelings of nostalgia? The point estimate is 0.260. So that is how many standard deviations apart are the two conditions. The p-value, as we saw in the appendix B, that's how likely is it, or what's the probability you would get this result if the null is true.
Really quick, how do you know which one is which condition?
So that you get from here.
Okay.
So I'm looking at the second one. How often have you experienced nostalgia? Time versus places.
Okay.
So that's the mean nostalgia for the time condition, and this is the mean nostalgia for the places condition.
Okay.
And then we go down here for the t-test information.
Okay.
And then finally we go down here for the effect size, which is Cohen's D here. So for Cohen's D, so you go, we're looking at the nostalgia variable. So you go down to Cohen's D, get the point estimate. So the point estimate for Cohen's D, which in this case is 0.260. So a quarter of a standard deviation between the two conditions. That's how big the mean difference is. And then the last step is these two, which is the 95% confidence interval for the effect size. So that is, we're 95% confident that the effect size in the population is between these two numbers. So we're 95% sure that the real effect size in the population is between minus 0.517 and 1.032. Okay, and then you'll do the same thing for your other dependent variable. So we'll do that here. Obviously, I have higher and lower here just as placeholders. You make it accurate for whether, which direction the effect is in, obviously. And make it accurate for whether it's significant or not. Okay, so we're 1 minute over. So I will stay as long as you want, within reason. So as I've already said, you're free to go. Show of hands, who's confused and wants me to come talk to them? All right, so I will come and talk to those people.